Good morning. On behalf of the Esco Group, I would like to welcome you to today's webinar. My name is Randy Peaty. I'm the Vice President of Program Development. I will be monitoring the control panel and answering some of the questions as Earl Delat, our Resource Development Coordinator, presents the presentation. Before we get started, we want to inform you of our webinar format. We want to be respectful of everyone's time, so we'll end our presentation within an hour. All attendees will be muted throughout the presentation. You may submit questions through the control panel using the question toolbar or by sending a message through the chat feature. If time allows, we will answer as many questions as possible at the end of the presentation. If we're unable to get to your question, we will follow up with you by email. This is the final section of the 5-part webinar series. This webinar, just as the others, will be recorded. It will be added to the Resource Center within a day or two. Remember, you must use the Proctor login to view the recordings. The recordings can be found under the Resource Center link after you log into the Esco Group website at www.escogroup.org. Now I would like to turn the webinar over to my colleague, Earl Delat. Thank you.
Thank you, Randy, and welcome everybody. Many instructors may be intimidated by Type 3 low pressure of the EPA Clean Air Act. I personally think this is the easiest part of all sections. Even if you have not worked on low pressure systems, between the Esco EPA manual and our PowerPoint, you should not have any problems conveying the information to your students or technicians. Most low pressure appliances are used for comfort cooling and are subject to a lower allowable leak rate. Technicians maintain, service, and repair or disposing of low pressure appliances must be certified as Type 3 or universal. So how do we teach low pressure if we've never worked with low pressure equipment? First, read over Type 3 very carefully. Second, if you're not sure about something or how it works, ask questions. We are more than willing to help you all we can. Third, if there's a low pressure facility close by, visit. Most of the engineers are usually very willing to give you a tour and answer any questions you may have. Fourth, all exam questions are answered in the Esco EPA manual, usually highlighted in red on the PowerPoint that comes with the manual. For many years, CFC R11 was the low pressure centrifugal refrigerant of choice. For environmental reasons, HCFC R123 became the low pressure centrifugal refrigerant of choice up until now. New replacement refrigerants such as HFC 245FA or HFO 1233ZD, as well as others, are now coming online. Or 1233ZD, which is a low pressure fluid with very similar operations to R11 and has the advantage of a slightly higher pressure and also has an ASHRAE rating of A1, which is not flammable. There are only 4 pressures to remember, and I guess this is why I tell everybody, to me, this is the easiest. 10 PSIG, maximum test pressure, maximum pressure for recovery machines. Pressure should never exceed 10 PSI. This is set for a safety margin for most low pressure systems. Number 2, the 15 PSIG only applies to the ruptured disc. Number 3, 25 millimeters of mercury absolute is what our recovery level is. And then finally, number 4, 1 millimeter of mercury to a level of above 2.5 millimeters of mercury is the standard vacuum test. These are the pressures that's important on type 3. I tell all exam takers, when in doubt, go with 10 psi. Stress that 15 is your ruptured disc only, and the 25 millimeters is for recovery levels. Because a low pressure system operates below atmospheric pressure, usually in a vacuum, leaks in the gaskets or fittings will cause air and moisture to enter the system on the low pressure side. Refrigerant doesn't really leak out unless the temperature is above 60 to 85 degrees Fahrenheit, depending upon which refrigerant is used. Air may leak in at lower temperatures. Review this on the pressure temperature chart on the back of the EPA manual with students or test takers. Low side pressure is operating low pressure systems or in a vacuum, while the high side pressure is usually under 10 psig. The common temperature of all 123 system in the evaporator would be 38 degrees with a corresponding pressure of 18.7 inches of vacuum. Therefore, it's important that exam takers know how to use a PT chart. Can't stress that enough. Remember, low pressure chillers require purge units because they operate below atmospheric pressure. As you can see, one of these are shown on the slide. The purge unit is a small, independent, separate refrigeration system that separates refrigerant from the non-condensables, then returns the refrigerant back to the chiller. The remaining non-condensables, usually air, is then vented to the atmosphere. The purge unit gets its suction from a connection on top of the condenser where most non-condensables will accumulate. After separating the air from the refrigerant, the purge unit sends the refrigerant back to the evaporator. These are usually test questions on most tests. High efficiency purge units are purge units that discharge a low percentage of refrigerant with the air they remove. Remember, high head pressure is an indication that air is in the low pressure system and the purge unit may not be operating properly or shut off. Excessive or increased purge runtime and abnormally high condenser pressures could be a sign there's a leak in the system. A well-maintained refrigeration system without leaks, the purge unit will record little or no purge time. A hydrostatic tube test kit is used to determine if tubes are leaking. When leak testing a low pressure centrifugal chiller with nitrogen, the maximum test pressure is 10 psig. Remember, the ruptured disc fails at 15. Charged low pressure refrigeration machines may be most efficiently leak checked by adding heat with circulated hot water or heating blankets. This will increase refrigerant pressure to slightly above atmospheric pressure. When checking for refrigerant leaks on the water side of a chiller, place a leak detector probe in the drain valve opening of the water box with all the water removed. It's important to remember to drain the evaporator and condenser water prior to recovering refrigerant from a chiller suspected of having tube leaks. Open drive type compressors are susceptible to leaks from around the shaft seal. This should be the first place to check for a leak, especially if it's been off for a long period of time. According to ASHRAE Guideline 3, The system should be checked for leaks if during a standing vacuum test, the pressure in the system rises from 1 millimeter of mercury to a level above 2.5 millimeters of mercury. This is on most exams, so stress this to your exam takers. This is usually one of those questions that's on probably 90% of the exams. EPA leak repair requirements apply to all appliances using a regulated refrigerant. Once the threshold leak rate has been exceeded on a system using an ozone depleting refrigerant with a charge of 50 pounds or greater, the owner must repair the appliance to bring the leak rate below the threshold or retrofit or retire that appliance. This is the same as in type 2. So if they know, if students know what's going on in type 2, this is an easy question because this is just kind of a repeat of type 2. As of January 1st, 2019, the applicable maximum leak rates are 10% of charge per year when used with comfort cooling, 20% of charge per year used for commercial refrigeration, 30% of charge per year when used for industrial process refrigeration. This is also the same as type 2. Chillers generally belong to the EPA leak repair category of comfort cooling. When used in multiple categories, the applicable maximum leak rate is determined by the highest percentage of use. Example, if a company diverts 55% of the chiller's cooling capacity to one of its manufacturing lines and 45% to cooling capacity to air conditioning of office spaces, the chiller is considered industrial process refrigeration leak rate category. Again, nothing has changed. This is the same thing as type 2. Use the charge stated on the equipment nameplate to determine chiller's normal charge for leak rate calculations. The leak rate of an appliance using ozone depleted refrigerant must be calculated when topping off or recharging the system due to loss of charge. This is new. If an appliance with 50 pounds or more of regulated refrigerant charge has exceeded the threshold leak rate, the owner or operator has 18 months to retrofit or retire the appliance. If the replacement appliance will be used a refrigerant exempt from venting, not having a certified service technician available for service cannot be used as a reason to extend the appliance leak repair deadline. Also, mothballing a system does not require removing the appliance and storing it in a warehouse at the facility. Test questions. If an appliance containing 50 or more pounds of ozone depleting refrigerant has exceeded the threshold leak rate, the owner or operator has 30 days to repair the appliance so that the leaks below the threshold and conduct the initial verification tests. This is also new. If a chiller with a charge of 200 pounds of ozone depleting refrigerant has passed the initial verification leak test, a follow-up verification test must be conducted within 10 days. Again, this is the same as type 2. The owner and or operator of the equipment is responsible for and must keep records of all leak inspections, initial verification, and any completed leak repair follow-up verification test for 3 years. Recovery techniques. The high pressure cutout on the recovery unit used for evacuating or recovering the refrigerant from a low pressure chiller is typically set at 10 psig. The question is, why 10 psig? This gives us a safety margin of 5 psig before the ruptured disc fails at 15 psig, releasing a large amount of refrigerant. Remember, EPA uses the term evacuate, meaning the same as recover. Kind of keep that in mind because this messes a lot of people up. Due to the volume of liquid refrigerant in large systems, refrigerant removed from a low pressure system starts with liquid removal followed by recovery of vapor refrigerant. After all the liquid has been removed, an average 350-ton R123 chiller at 0 psig would still have approximately 100 pounds of refrigerant in the vapor space. The use of severely oversized vacuum pumps could cause trapped water to freeze when evacuating or dehydrating a system. During evacuation of a system containing large amounts of moisture, it may be necessary to break the vacuum using nitrogen. Increasing the pressure with nitrogen prevents moisture from freezing and increases the speed of dehydration time. A water-cooled recovery unit will allow for faster recovery of large quantities of refrigerant. To prevent water from freezing in the appliance during recovery or charging, the water pump should be on. This is going to be important coming up. There's a question, we'll explain why this is important. The system water pump, recovery compressor, and recovery condenser water should all be on during vapor or liquid refrigerant removal from a low pressure system. Raising the temperature of the room in which low pressure chiller is located will help speed up the recovery if the recovery cylinder is not also being heated. Remind exam takers that if a question is asked about what should be on, what should be off during the vapor removal, it's easy. Everything must be on, nothing should be off. When removing refrigerant oil, it should be heated to 130 degrees as less refrigerant will be contained in the oil at higher temperatures. Remember, be extremely careful when heating a system because the ruptured disc on a recovery vessel for a low pressure refrigerant relieves at 15 psig. After reaching the required recovery vacuum level on a low pressure appliance, wait a few minutes to see if the system pressure rises before charging. This is the same on all sections of the exam. When leaks in the appliance make evacuation or recovery to the prescribed level unattainable, do not proceed with recovery. This is also the same on each type of EPA certification. Recovery and recycle equipment must be labeled as certified to meet EPA requirements. A major repairs considered replacing or repairing parts of the system such as compressor, condenser, or evaporator. When making a non-major repair, warming the liquid refrigerant in the system with hot water or warming blankets will bring the system pressure out of a vacuum. This is so that air moisture does not enter the system. Usually you want to bring that to atmospheric pressure, right at 0. Before disposing of a low pressure appliance, the refrigerant must be recovered or evacuated to 25 millimeters of mercury absolute. Recovery records for disposed appliances with 50 pounds or more of refrigerant is still in effect. And now the 5 to 50 pound of refrigerants are not included and must be kept for 3 years. Before evacuation or recovery or dehydration, an oil sample should be taken if the unit has a compressor burnout. Also, when evacuating or dehydrating a system that contains a large amount of moisture, Triple evacuate and dehydrate the system using dry nitrogen to break the vacuum. Increasing the pressure with nitrogen will prevent moisture from freezing. After servicing and evacuating a chiller, refrigerant vapor should be reintroduced into the chiller as the vapor to the pressure which corresponds to the saturation temperature is above freezing. Usually this is around 36 degrees Fahrenheit. This will prevent liquid refrigerant charged into a system from freezing water in a heat exchanger tube bundle. An example, liquid charging R245 FA into a low pressure refrigeration system in a vacuum greater than 18 inches of mercury is somewhere around minus 7 degrees Fahrenheit. Vacuum will cause the system water to freeze. But if we get all the way down to 29 inches of vacuum, the saturated temperature would be a minus 60 degrees. So it's important to make sure we bring up the level of pressure with vapor before introducing liquid into the system. If not, you'll be repairing a whole lot of tubes. When reviewing the saturated condition on a PT chart, an evacuation or dehydrated water-cooled chiller system with 123 should have vapor pressure above 20 inches of mercury, which is 36 degrees. Vacuum before adding any liquid refrigerant. Again, it's important to be able to understand how to use a PT chart. This is one thing that, especially on type 3, there are quite a few questions that deal with the pressure temperature chart. A liquid refrigerant is charged into the system using the evaporator charging valve. This is the lowest accent point on the low pressure appliance. In the picture, you can see pretty much where that circle is, where this is at. Note, the relationships found on pressure temperature charts will vary slightly from one manufacturer or publisher to the next. The pressures are normally indicated in PSIG. To convert from absolute PSIA to gauge pressure, PSIG, subtract 14.7 from absolute pressure. Therefore, 14.7 PSIA equals 0 PSIG. To convert PSIA to inches of mercury below atmosphere, just simply multiply it by 2. An example, 1 PSIA equals 2 inches of vacuum. And again, make sure that test takers can do this for different pressures. When the threshold limit value, time-weighted average, is exceeded, ASHRAE Standard 15-2013 requires that each machine room activate an alarm and turn on a mechanical ventilation system. Again, this is definitely on most tests. ASHRAE Standard 15-2013 also requires the use of room sensors and alarms to detect refrigerant leaks in all refrigeration safety groups. All 123 refrigerant is classified as B1, non-flammable, high toxicity, and refrigerant R1233 is classified as A1 under standard 34 code group. This you need to go over a lot with students and test takers so they understand the difference of A1 versus B1 on the test. The use of room sensors and alarms to detect refrigerant leaks in all refrigerant safety groups is required, not only because of refrigerant characteristics, but because refrigerants are heavier in air and displace oxygen. All refrigeration systems must be protected by pressure relief valves. If more than one relief valve is required, they must be piped in parallel, not series. Another safety device is the ruptured disc located on the evaporator of a low pressure chiller. A little bit about the pressure relief valves. These valves are designed to be in parallel and usually piped outside. And we'll talk more about that in a second. Let me go back to that. On the test, a lot of people get confused about the valves being parallel or series. Just remind everybody that if they're in series, that means that the first valve would have to open and then the next valve. So there would be a delay. And sometimes those few seconds can be pretty precious as into what happens with refrigerant. And that's why they have to be piped in parallel. We will now take questions if anyone has any.
Earl, we have one question about the standing pressure test and not using 500 microns. We're looking at two different things here. When you're working on a low pressure chiller, you're normally looking at a chiller barrel and a condenser, water tubes, and so forth. You don't want to pull the system into a vacuum before making sure it doesn't have any leaks. If you do, you could pull moisture into the system. So the standing pressure test with nitrogen is basically a time to rise method where you pressure it up and you watch your gauges to make sure that it doesn't rise any more than 2.5 millimeters. Because this needs to be done, again, to prevent water from entering the system if you still have a leak.
Yeah, great point. Any other questions?
Don't see any coming in. So must have answered all the questions through the presentation.
Well, hopefully did. If not, they can contact us through our emails. We'll be glad to answer any additional questions that may come in. Thank you for your time. This will end the Esco EPA series webinar. Remember, all 5 recordings will be posted under the Resource Center link in the Proctor login area of the Esco Group website. If you have any additional questions, please contact Randy or myself by email or a member of our customer service team at the phone number of 1-800-726-9696, Monday through Friday, 8 a.m. to 5 p.m. Central Time.
Thank you.